Very good morning to all of you. Let's do another numerical problem on the topic bandwidth and signal to noise ratio trade-off. The statement for the problem goes like this. For a standard voice band communication channel, the SNR is 30 dB and the transmission bandwidth is 3 kHz. What will be the channel capacity and Shannon limit? So again we are asking the value of C and the value of R max. So we have ready-made formula for them, both of them we have derived in the last lecture. But before we proceed further, we need to convert the SNR value given in dB to a unitless numerical value. Okay, so let's start by converting this 30 dB value of the SNR into a unitless ratio. So what is 30 dB? 30 dB is equal to, let's reconvert it from the log value, 10 log 10 of the SNR. Now 10 log 10 of the SNR is 30 dB. So what is the value of SNR? Let's transpose these values and we will get the SNR is equal to 1000. Now we can directly substitute this SNR value into the formula of C. Formula of C is bandwidth multiplied with log of 1 plus S by N. So we are going to have 3 log 1001, and this log value is 10 base. Remember, it is base 10. That comes out to be 3 into 3.32 log 10 into 1001, which in turn becomes 3 into 3.32 into 3, and that will become 30 kbps, 30 kilobits per second. Okay, so that is the channel capacity for this given problem. Now we need to calculate R max. To calculate R max, we need to have the value of ratio between the signal power and noise power spectral density. So we need to have this value, which is S by N is equal to 1000. So what will be the value of eta in this case when we know the signal power S and the bandwidth W? When we know these two values, we have S upon 3000, which we have just now calculated, into N. Or we can say that we have this ratio is equal to 3 into 10 raised to power 6. Okay, let's remember this value because we are going to make use of this value in calculating the Shannon limit, which is the maximum information rate or max. Remember its formula in the last numerical also we had used it. So the value of log E there was 1.44, and that we had this value S upon eta multiplied with 1.44. So ultimately we have 1.44 into 3 into 10 raised to power 6, and this value has a unit of bits per second, and that will give us the value of 4.32 megabits per second. So this is the Shannon limit for these given conditions of a standard voice band communication channel. So ultimately we have to just replace the values in the standard formula and then we can get both the channel capacity and the channel limit.